Okay, welcome back, everybody. So today we're gonna talk about um, using agent-based modeling or system dynamics modeling. Can you see my screen okay?
Yep.
Perfect, thank you. So my name is Ruby Nguyen. For those who don't know me, I work at Idaho National Lab. I was with Washington State University a long time ago. So part of today's discussion, I'm going to talk about the dissertation that I did back in 2012. So I'm going to talk about the two case studies. So the first one is with National Park Management. That one, of course, it was on the borderline between choosing agent-based modeling and system dynamics. And luckily, I was able to answer my research questions with system dynamics. And then the second case studies, I'm going to talk about the farmer's behavior. And in that case, I started out with system dynamics and didn't have a lot of success. And finally, I have to learn how to do agent-based modeling. So the first one is about Glacier National Park. I don't know if how many of you have been there, but the Going to the Sun Road is the highlight of the park. So it was built in the 30s and up until 2007, then they wanted to rehabilitate the road. So this is the red line here is the Going to the Sun Road, so the west entrance here. And then right here is Logan Pass is the highlight of the road. So I think the project lasted for 5 years for the rehabilitation, and then the park introduced a free shuttle system to facilitate visitors, right? Because it's not easy to have all the road work and then people driving around and visit the park. And then the University of Montana, they did a lot of visitor surveys to understand the shuttle impacts. And the shuttle has multiple impacts and it's kind of hard to pinpoint. So of course, it helps reduce the car traffic. However, it increased backcountry hiking, and I will go into that a little bit more. But basically, because now people can take the shuttle and then hike one way to another destination and catch the shuttle again. Whereas before they have to do the whole loop, right? So it takes more time. And then because of increase in backcountry hiking, then the vegetation trampling and social trails were pretty bad. However, they didn't see any improvement in the congestion at the busy parking lots. So when I did this research, I have 4 objectives in mind. So first, to understand the parking lot congestion, right? Why there was no improvement, especially at major parking lots for a typical busy day in July. So it's like the peak time of a visitor at the park. I also wanted to look at the how visitors use different trails around the Logan Pass area. So if you're not familiar with the park, this is a simplified map. So if you enter at the west entrance, you will see the Apgar Visitor Center first. And then, of course, there are trails around here, but it's not as popular. And then you go up here, there's an avalanche area you can visit. And then you go another up here to the loop, then Logan Pass. And then the next map here I like to show, sorry, it's kind of cut off a little bit, but to zoom in this avalanche, the Loop Logan Pass area, then there's more trail here at Avalanche Lake. And then between the Loop and Logan Pass, this is the highlight trail. So normally people have to do the whole loop, but then with the shuttle, there's shuttle here and shuttle here, so they only need to take one-way hike. And then at the Logan Pass Visitor Center, you can visit that visitor center, of course, and there's Hidden Lake here, so you can take a little hike to this lake. And so overall, I wanted to evaluate the effect of the shuttle on the trail use and then provide, a tool for the park managers to test different policies. So the main feedback of this model, you can see the interaction between the trail, the traffic, and the shuttle. So if people wanted to use the car, right, they can park their cars, they enter the trail, so they on this trail, and then when they done, they can go back to their cars, so they participate in the traffic. But if some people, they want to avoid the traffic, then they can use the shuttle. However, at some transit centers, if it's too crowded, the line is too long, they don't want to wait, then they go back and drive the cars instead. And when shuttle riders at the different bus stop, right, they can leave the bus, visit the trails, and they go back to the bus. So, I mean, feedback-wise, there's not a lot going on. However, when we look at the system components, there are a lot of things going on. So talking about visitors, there are 6 different groups. So because they have different destination in mind, right? So they have different arrival time. And also the distribution, like how many, more people want to go to Logan Pass, for example, and less people want to take the longer hike. And because of the different destinations, they want to park differently at different parking lots. And if they fail to park at one parking lot, they have a backup plan on where they want to go. Now, we have 4 major parking lots, and then for the bus operation, we have 15 buses. And there are 2 times. The 44 seats or the bigger bus is for lower elevation. And then when you go up to the higher elevation, you can't use the big bus anymore, right? It's very rough turn. So you have to use the smaller buses. And then there are 4 different routes. So it's not simple. And then tracking the people is also hard. So you have to track visitors using the bus and also visitors using the car, right, when they go to the trail or when they go back to the car and continue their journey. Okay, so the question is, should we do agent-based or system dynamics? So I tried with agent-based a little bit. So I looked at, different papers and comparing between agent-based and system dynamics. I looked at the time, NetLogo example, because it's free for students. That's why. So I tried to follow some of the examples they have, and then I got stuck. Somehow, the code didn't work. And at that time, I didn't have a lot of coding skills, so for me, it's a no-go. On the other hand, if I choose system dynamics, then I have my advisor's help, right? But he has no idea on how to do agent-based modeling. So that's a big disadvantage. And then because I'm more familiar with system dynamics, so I chose system dynamics. So a little more on the model structure. So again, the 3 submodels here, and you can see, the shuttle part is very complicated because you have to track the bus, you have to track the people and connect to the trails. So I'm just trying to list different things here, but I'm not hoping that you can see everything. But in general, for the traffic, we have to have the arrival sector just to show different groups when they arrive, where do they want to go. And then at the visitor center, and then for the trail, so mostly the trails, tracking the shuttle riders versus the people driving the cars. Okay, so I used Stella for this purpose, and I know it's not easy to see. What I'm trying to show here is I use arrays for the purpose of, dividing into different groups of visitors. I use conveyors because, try to capture the movement from one place to the next. and when people park at certain place. And then also, yeah, so and then tracking the total cars parking at a parking lot. If these people fail parking, like where do they go next? And for the shuttle submodel, so there's a lower elevation bus here. So there are buses in the pool, and at different start times they leave. So empty departure, they go to the next transit. Um, so people get on and they continue their route. So there are 4 different routes. And then when the transition between the lower elevation and then the higher elevation, then there's a different bus that need to be operated here. So all of these are conveyors and arrays. And again, the feedback is not super complicated, right? So for shuttle people, if the waiting time is too long, then they go back and drive their car. That's the main feedback loop here. And so I think the easiest way to kind of show this model was, for the model interface. So again, the simplified version of the road at 4 major parking lots here. And so for example, it's 10 o'clock in the morning now. And the indicators of different parking lots, right? So up to 70% full is still green, yellow between 70 to 95%, and then red 95 to 100%. So at 10 o'clock in the morning, you can see all parking lots here are full. And these are the number of cars that are parking. And also talking about the traffic, these are the number of cars driving, on each of the row segment here. And then there are, buttons like you can turn on and off the shuttle operation. You can change the fraction of visitors entering from the west side. You can change the number of annual visitors in millions. And then you can also test the shuttle factor, meaning if you double the number of people using the shuttle and things like that, or understanding the changing the parking lot capacity. And this is the interface for the trail. So again, you can see how many people on each of the trail segments, or the people at, certain attractions here. So for that one, I'm not going to show, the results. It was a successful case study, but with a lot of complexity, of course. So the second case study here, I'm going to talk about the farmers' adoption. So we had a project where, for energy crop, we're not sure how farmers will adopt it, right, based on their current practices. So we need to determine the market strategies to reduce the near-term supply chain costs for establishing the supply chains and also the operation costs. And of course, the Department of Energy, in order to have more adoption of biomass, bioenergy, we have to increase the grower adoption of energy crops. And the other thing we would like to know is the spatial distribution of the supply shed, right? So where the farmers are and what is the proximity to the transportation network, which will impact supply. So my first attempt was with system dynamics, right? So if you're in the Midwest, the farming, there is a lot of corn and other rotation. So the way I tracked land use here is that, so for rotation, you need to have a memory of the previous crop. So for example, this land is the past two crop is corn. So you can't do another third crop of corn. So you have to go to wheat, for example. Then we have corn wheat. So after you have corn wheat, then you can go back to corn. Or you have corn, then you want to go to soy to break out the corn cycle. So we have corn, soy, and let me think. Yeah, so wheat, corn back, or we can do wheat, corn, wheat, or wheat, corn, corn, right? So in general, we can't do 3 crops of corn in a row. So we have to break in a wheat crop or a soy crop. So that's for the irrigated farming. For the dryland farming, it's a little different. So if you start with wheat, in the next crop, you might want to have corn, and then you go to fallow. So after corn, because the soy is so the nutrition is kind of depleted, so you want to go to fallow. So after fallow, you can go back to wheat, and then from wheat you go back to, or you can have, or you just do wheat, fallow, fallow, wheat. So that's what people do there. So the results here, you can see the irrigated farming. So at the end of the day, right, when we look at USDA statistics, something like that, we always say, okay, what is the total corn area or total wheat areas? But it's hard to say, okay, what is the breakdown or the previous crop? And so for this model, I was able to say, okay, this is a total irrigated. It's kind of bouncy. But then we can have the breakdown, what is the corn soy and then what is the corn wheat. So we can see more corn soy than corn wheat. And for the dryland, not much change here. Although this model is based on, profit optimization, like we have the crop budget and we see the difference between yield and then that impacts the profit. And with system dynamics, we can also do sensitivity analysis. So depending on the prices, the costs, and the corn yield after the rotation, they can have, the change is mostly here for the upcoming, the last period of time. So it wasn't really desirable to use system dynamics in this way. So for that, we have to switch to agent-based modeling. So with agent-based modeling, we have to look at farmers very closely and the farms. So within the farmers, they have different age structure. And that impacts, or we can look at the farmer life cycle. They have different ways to make decisions depending on the age. So if they're closer to retirement, their adoption of crop might not be the same as someone who just started their career, right? The farming. Also, the different farmers have different innovation level, and they have risk preference. So some of the risk takers, and they love to innovate, so they are early adopters. And then we also want to see, the network of farmers, because that will, so one farmer adopts, and if depending on how large his network is, he might have an influence on other adopters. For the farms, the farm size is one thing, and the quality of the land is another thing. And then, when people retire, there are 2 options, right? Either they have children to take over the land, or they sell the land to a neighbor. So that's another dynamic. And then the factors that impact their decisions are the dynamics of the market, and also like how they are impacted by the media. So for example, if you hear something on the radio once, you will forget about it. But if you hear it on the radio, you watch it on TV, you see it on the news feed, that it becomes something more, then you can't really ignore it. Now you start to be curious and want to understand, learn more about that. And also the social networks say, if you hear something on the TV, it's not as impactful as someone telling you, right? So we see commercial all the time, but then if somebody say, oh, I use this product and it's really effective, then it changes your perception. So those types of things we cannot capture with system dynamics. So here I just want to show you one concept in agent-based modeling. So I use AnyLogic, and it has a state chart functionality. So for example, if we look at the farmer's life cycle, right? So they're beginner farmers, so we can define at certain age. And then after a certain number of years, they become mid-career and they become senior farmers and they are about to retire. So when they're reaching retirement, they can, so there's a little delay. So this is a time transition. So, okay, we assume that there's some time for the farmers to get ready for their retirement, right? So either they hand over to their kids, so those will be beginner farmers again, or they can sell it to their neighbors. So if they sell it to their neighbors, the demographic of the farmer is the same, except that they're gonna retire here. And on the crop state chart, so we look at whether getting the biomass from crops at residue or from energy crop. So there are different levels of the farmers. So initially they're unaware of any of the practice, right? Unaware of residue harvest or energy crop. And then they can, so this is a message transition. If they talk to their neighbors or they talk to the purchaser. So the purchaser is like the sales agent. They go out and talk to people about the potential to convert or the company would buy the products. So the farmers will be aware. But for some people, if they love innovation, they love to take risks, then they initiate the pilot farm. But for the rest of the farmers, they're just interested in the practice, but they're not done anything yet. And so when they consider the one practice, for example, it takes them, it requires some condition for them to adopt, and then they have to wait for the contract to be in place. And then therefore their status is to adopt residual harvest. And also there's a transition in here, like when they are in this status. So once they adopt, this is the word of mouth transition, is that they start telling their friends, the family, that they now adopt this practice. The energy crop is a little more complicated because this is a totally new practice, right? So when you grow something new, like whether you have to change your equipment or prepare your land differently. So there's a learning here compared to the crop residue, because with the crop residue, if you just let it sit in the field, but you do the no-till, now you harvest. So that's different. But then for energy crop, then you have to do the learning to see, okay, is it easy to grow or not? And then you can consider it, and then waiting for the contract. And yeah. Okay, and looking into the code a little bit. So this is just for the retire transition. So, and this is Java. So you can say here, like you have to use the array list. So to get a collection of the neighbors. And then you have to go through the list and say, because the farmers are connected to the land and the farmers also connected to other farmers or neighbors. So we have to sort this out. Is this a farmer, right? So we just want a neighbor farmer. And we want to make sure that, the list is not empty, and we choose a random farmer. And then let's see here. Yes. So this is the learning part where we say, okay, if this farmer already practiced residue or energy crop, when he sells the land to his neighbor, then his neighbor will inherit the knowledge because the land already has, or the farm equipment or the land already has that trait. So as you can see, this is just back to here, just this one transition. And so you can see how much coding you have to do. The other thing is back to here, like there are agents, right? So farmer is one agent, and then you have to initialize the population of farmer, say based on the age distribution and everything else. Same thing for farm. There's a farm. So the agent is like the cookie cutter, right? So, and then the population is how many of the cookies that you make. But then there's a main environment where these two interact, and so they have to pass information. So farmers pass information to the farms, and also between farmers. So just to give you an idea of how complex it is when you do agent-based modeling. And so this is another, so in addition to the aggregated chart that we normally see with system dynamics, with agent-based modeling, you can have this kind of visualization. So in this case, all the green, so each of these is a farmland. So the size is yeah, so a big rectangle represent a big farm, and the smaller one represent a small farm. And then so all the corn here is in green, on the blue is in soybean, brown is the wheat kind of hidden here. So magenta is in CRP land, and the yellow one is the energy crop. So that's the one we're kind of interested in. But what I'm trying to show here is that with agent-based modeling, the visualization of the model is a result on its own. And then, I mean, yeah, I'm not going to talk about the results here, but if you're interested, here is the paper. Okay, and I'd like to give time for more discussion, but in summary, for me, like when to use agent-based modeling versus system dynamics. So for system dynamics, we're more interested in the aggregated behavior. Whereas for agent-based modeling, now we look into the high level of heterogeneity and also how they make decision at the individual level. And then the inter-agent interactions are also very important. And sometimes we have emergent behavior. So if you think about the bird example, like how they travel in flocks, right? And then when they hit the wall and then they change the trajectory. But so the rules for those agents are very simple. Like they keep a certain distance with the bird in front of them, with the bird to the left, with the bird to the right. But then the outcome of their group pattern changes depending on the surrounding environment, like wind speed or obstacles, etc. So that's the emergent behavior that sometimes we don't see if we do, or most of the time we don't see if we do system dynamics. The other thing with system dynamic is when we initialize the model, most of the time we do it deterministically, right? So we have an initial value, we have certain transition rate, and then you run the model all the time. It's got to show the same type results. For agent-based modeling, it's very stochastic. So for example, the farmers, so say 50% is, so you have a distribution of the age and then also the distribution of the farm size. But every time if you have a different seed, every time you initialize the model, then the distribution, like which farmer owns which land, it will change. And so for that, in order to have representative results, like you have to run with different seed numbers, so to have different distribution of the model. So even though the aggregated distribution is the same, but the actual individual level is different. And then when you have a different sets of results, then you have to do more statistical analysis of the results. As you know, with system dynamics, the geospatial aspect is kind of limited, right? So in the case of the national park I showed you, this is a very simplified version. And then you can see, so explicitly it doesn't have the geospatial aspect. And then we just have, different stocks to capture different areas, and then we kind of present it on the map. With the agent-based modeling, because it can be connected to latitude and longitude, so it's totally spatially dynamic. The other thing with system dynamic is when you look at the level of complexity in terms of feedback, it is more helpful to use system dynamics. For agent-based, some of the times, there are not a lot of feedbacks. So one example I can give is, so if you design a gallery and you're not sure where to put different display, so you can do an agent-based model there, right? And then you can say, okay, where do people kind of stay for a certain time and move to the next, and what's the spatial distribution of that gallery. But again, there's not a lot of feedback in that model, and the visualization of the gallery itself is a model result. And then I think the last element here is the limiting factor too. So if you don't have a lot of coding skill, then agent-based modeling is not for you. So for me, it took a couple of years to, first to learn, of course, the Java or Python language, and then understand like how to think in agent-based modeling versus, how to think in stocks and flows. It's a totally different type of thinking. But I think the key thing here is when we choose any modeling method, we have to answer the question of, does this method help answer the research questions? Of course, we have limitation on, coding skill, etc., but it should not be the deciding factor in some cases. So if we were to, really try hard to answer the research questions. All right, so with that, I'm going to stop here for, questions and more discussion.
I have a question. I have a lot of questions, actually, just because I took some notes. How do you go about doing your decision making by farmers? I mean, is the outcome they get from, let's say, the previous 2 years' crops, like if they're growing corn and they have, good yields and so forth, do they stick with that, or are they set in the way they do things because of the need to have some turnover in their fields using different crops. I mean, I'm sort of curious, I mean, obviously they may change their ideas if the price of one of these items is increasing a lot. So I mean, how do you incorporate that into the model?
So I think it's that level of complexity that I feel that system dynamics cannot capture. So we can normally, right? So we look at the physical system, then it's the land area, and we do the optimization based on the prices and everything. But then again, it's at the system level. It's not at the individual farmer level. And also for different farmers, they value different things, right? So if you're closer to retirement, you don't want to change your farming practices very much. You might value conservation more, right? Compared to your kind of young farmer, then you might, well, depending on your different stages, right? So if you're a very beginner farmer, you want to be successful, so you don't want to try to deviate too much. But if you're mid-career, maybe you're comfortable with your current practices, and then you want to try something new, right? So you're at a different position, and then when you're close to retirement, you don't want to do a whole lot. So those are the things it's hard to capture with system dynamics.
Well, I guess I was thinking more in terms of a strategic approach where you wouldn't really be too concerned about individuals, but about trends. I mean, when corn ethanol became more, corn for ethanol became part of the market, the soybean crops went down quite a bit. I mean, there was a real drop in soybean production. It didn't affect the US very much, but it did affect our exports to other countries, which affected the price of soybeans in Southeast Asia, for example. And so from a strategic point of view, I mean, a lot of farmers saying, hey, I think I'll grow more corn and less soybeans. I was sort of thinking about how do you incorporate that kind of decision making, because it's obviously something to do with pricing and what kind of return they're going to get on their cropping system.
Right. So, I mean, if you were still want, and I mean, maybe in the case you described, we don't need to go agent-based modeling, right? And so from all these supply of different commodities here, wheat, corn, or soy, and then we have a demand, then we can calculate, of course, the demand curve and the elasticity of demand, things like that. We can calculate prices. And then, the transition here, it will be impacted prices. So that's how I think you can do it if you want to stay with system dynamics. I'm not sure if that is helpful.
Yeah, no, I'm just sort of curious. Another question I had was when you're talking about energy crops, what crops are you talking about?
So we're talking about switchgrass.
Uh-huh.
Yeah.
And is there actually a market for that yet?
So I haven't worked with that project for a while, but I think a lot of that is still, piloting or experimenting.
Yeah, I was in a seminar a couple of years ago, and the guy who gave it has been working with switchgrass and some other of those energy crops in upstate New York. And he said one thing he had to tell the farmers, he says, do not grow this crop unless you have lined up someone who's going to buy it, because its transport for it is limited. Even if you have a buyer, they have to be fairly close by because it's bulky. So anyway, there's a bunch of other things in the energy crops. I mean, corn is, in the US at least, is considered an energy crop. Not a very good one, but nevertheless.
Yeah, so you mean the corn stover, the residue?
No, I was thinking of corn, using corn for ethanol.
Oh, okay. Okay.
I mean, but anyway, the only other question I had was with system dynamics, we have these tools for validation, and I was wondering what you'd come across for agent-based modeling. I know there's some attempts to look into that, but I'm not familiar with them. there any ways to validate agent-based models?
Yeah, I think that's a very good question. I mean, the case that I was working on is totally hypothetical. So we kind of say, rely on the what if and the general pattern of the adoption, right? So say, okay, at the end, is it evolve into a S-shaped or something like that? But yeah, that's a really good question. And even now, when I have a current project on agent-based modeling for the potato supply chain. We can validate in terms of production. Again, prices are hard to validate because, the model doesn't only takes into account supply and demand. It doesn't take into account any historical event that happened that impacted the prices. So yeah, when we compare against historical prices, it's not useful. So we mostly do on the mass balance.
Yeah. And anyway, I'll let somebody else ask some questions if there are any.
Sure. Who wants to go next?
Well, I'll throw something out there. So in your agent-based model, and maybe you said this and I didn't catch it, did you capture farmer-to-farmer learning?
The learning process?
But, right. So when one farmer is successful, his neighbor's going to sit there and watch. Mm-hmm. And then once they're fairly successful, maybe the neighbor will adopt.
Yeah. So that's the part, talk to the neighbors here. But in the adoption part here, so it depends on the risk preference. But we also looked at, which farmer has the most impact. And most of the time, the large farmers, right, when they can demonstrate on that large farm, and their influence is much larger than the teeny farmers.
Mm-hmm. There's an interesting, I don't know if you've seen Montgomery's book, Growing a Revolution. And he talks about a case study in South Dakota on adoption of seed drills. And it's a pretty compelling argument on farmer-to-farmer learning. So if you haven't read it, and if anybody hasn't read it, you should read it. It's a great book on actually transforming agriculture fairly easily to save soils,
right,
and increase production.
Yeah. Yeah, thank you for that, Allison. And I think, the challenge about agricultural adoption is sometimes you see the inertia is too high, but at the same time, when something clicks and it's spread out like wildfire, right? Like and then you can see adoption, like mass adoption. And in the case of, shrimp farming, it was the profit that, driving the mass adoption because it's much more profitable than rice farming. Mm-hmm. But I think for others, profit is one thing, but yeah, it's hard to say. But in the case of shrimp farming, it was the profit that, drove the mass adoption.
Right. Yeah, in the South Dakota case, it was soil loss for the most part. They had places, this guy was describing, where, on a windy day, they had to get the snow plows out to clear the dust off the roads. It's how extreme it was. And the air quality, the sky was just brown all the time. And then once this adoption sort of took off, and it took off like wildfire to using seed drills, they don't have that problem anymore. And in several of these counties where they just did it. And you drive around and there's new grain silos everywhere. So actually the production went up.
It sounds like a direct link to profit from a business perspective, right? And I think the tipping point, right, is clear, right, Ruby, exactly what you're talking about, right, is using the system dynamics models to identify what levers are critical and how do we find the tipping point so we can make things happen that we want to. right? And I'm curious. So one of the things that I really liked about and thanks for doing this, it's really informative, is on the agent-based models, that heat map you have of like what they were growing, right? So there is a bit of me that really likes that visual for showing almost a tipping point, right? And what the kind of end impact of that is and how you can reach that. And what tools are you using to do that, and how did you get to that point?
So it's called AnyLogic. It's not a free software.
Of course not.
Uh, yeah, it's pretty pricey. I'm not sure because I'm with the national lab. Maybe with the university you can get a deal. But the way it works is, you sorry, I don't have the license right now with me to open
Oh, that's fine. I can go ahead and
mode.
take a look. That's plenty.
Right, but I mean, the way you work with that software is you have to think about, creating the agent, and within that agent, so agent is again like cookie cutter, right? So you create a cutter, so you have to think about, okay, with this agent, what are the key parameters or variables you want to capture, and then how many agents you want to create. With AnyLogic, the way they define agent is very loosely. So for example, if you want to look at how people grocery shopping behavior impact their weight. And so you can go to a full-blown grocery store, or you can go to a convenience store, right? And so in that case,
a little bit like a Monte Carlo where the seed set or the starting point makes a difference as well.
Yeah, that's true. And in this case, you can set the grocery store or the convenience store as an agent. So just to show you how loosely the software define an agent, and like how to decide if something is a parameter or a variable versus an agent, mostly because if you feel like that object has more connection and more dynamics in it, or it contains too much information, then with the software, you want to create an agent. And then in the main environment, that's where all the agents interact, and how you do the aggregation of the statistics, or passing information, and then how you initialize the model. So for example, now you want 10,000 farmers, and 10,000 farmland, and then only 3,000 farmers, something like that. Yeah, the state chart that I showed before here is kind of helpful. So sometimes you can think this as different states of the agent, but it could be similar to the stocks, right? So yeah, you can have a stock of beginners and mid-career farmers, etc.
Yeah, I was thinking about showing invasives, right, and propagation of invasives. So that's where I was looking at this, going, oh, that's a nice visual, as opposed to just a stock that's 20% full or 90% full. This is nicer to see kind of how that grows and show it over time.
Yeah, but I mean, for the state chart, it could be more than just a stock idea, right? So if the farmers, they're not considering any new practices, so that's a state of mind, right?
Yeah.
And where, I mean, of course, sometimes you can use this as a stock flow thinking as well. Yeah, but it's slightly different on how you have so the question mark is the condition. So it has to meet certain condition, then it moves to the next stage. Or if it's a message type, so when it receives the message, so the farmer say, oh, I adopted, and then it changed the state of these agents. Mm-hmm.
Yeah, and then did it work or not, right? I'll never do it again, or I go forward and do it again, and other people follow, right? Mm-hmm. So, and you mentioned that you thought system dynamics couldn't handle kind of the influencing, if you will, or the advertising and that type of thing. Did I understand that right? I was confused by that because I guess I'm so used to seeing influencer models that surprised me. So I'm wondering what I missed on the nuance.
So I have a shrimp farming model as well. It was done in system dynamics. In that model, I did look at the peer learning and how the pilot farm impacts the mass adoption. But again, it's very similar to say, so from here to here, right? So you might have a relationship between the profit ratio and how many farmers transition to the next stage. But it might not be powerful in a sense that, okay, you talk to the neighbors or you heard it from the media, how many times or you heard the same news, things like that, then it won't be helpful.
Got
Okay,
it. And I think I saw your shrimp farm at the System Dynamics conference, right? Did you present that? Or not?
Well, it was a long time ago.
Oh, got it. Okay.
I mean, I can send you the paper if
No,
you're
that's okay.
interested. Yeah.
All right. That's
Yes.
helpful. Thank you.
Rakshinda, yes, the recording will be available. So I will upload it to the drive of the SIG, and then I posted on LinkedIn of the group, and I will also send a link via email. Okay, anything else?
I was wondering, have you looked at regarding the cropping models? Have you looked at any of the standard? I mean, there are a bunch of cropping models. I don't know what the names of them are, and I just know that people here teach a course where they use some of these cropping models to look at these issues of sequential cropping and how the landscape is changing and that sort of thing. And there are some, I guess you'd call them pre-packaged cropping systems models that people use in agriculture. And I wonder if you've come across those or had any opinions about them. I don't know anything about them except I know they use them. And
so Richard, when you say cropping model, did you mean like how the plants grow given nutrients and water and things like that?
Well, there are that as well. That's part of it, but I think there are more farm management models that farmers can use or learn how sequential cropping of different types works. I really don't know enough about them. I know they call them cropping systems models, and anyway, I don't know enough about them to ask a proper question, I guess.
Yeah, I haven't looked into those a lot. I know, there's a field of modeling where you look at the physical, like finite element, like from one soil particle to the next, and when you do erosion modeling and things like that.
Yeah, these are more farm management, more incorporating the business side and how to make decisions based on what your past experience and what was grown in the field last year and that sort of thing. Yeah.
Yeah, I'm not familiar with those, sorry.
I just wondered if those overlapped at all or not. I guess I should ask my colleagues.
Yeah, that'd be helpful. Yeah, tell us the answer when you know the answer, okay?
Okay.
Okay, anything else? Yeah, I still need volunteers for upcoming meetings. So yeah, if you have any ideas or you need help with your modeling effort, yeah, please volunteer. All right. Yeah, so it's the end of the hour. So thank you everyone so much for joining. And if you have any suggestions or concerns or comments, feel free to email me. And yeah, thank you again and have a good rest of your day.
Thanks, Ruby.
Thank
Yeah,
Ruby.
thanks a lot.
I would say AnyLogic does have a free learning edition as well, the PLE. Just
Yeah.
FYI.
Yeah, I think that they don't have, if you want to run Monte Carlo experiments and things like that, it's not available. Plus there's a constraint on how many agents you can create. But I assume that if you just started, you just want to create a simple model.
Yeah.
Yeah, for getting started, it's reasonable.
Yeah.
But you
Although I
can't.
don't really want to get started learning something that I can't actually afford to buy the
Yeah, right.
full one.
Well, I never got very far with it. But it is fully functional, but you can't build big models, but it's good enough to get started on how to do it.
Yeah, it's a powerful tool though. I mean, we can do hybrid modeling with it as well. So you can have some agent-based level, but you can also aggregate it and have a system dynamics components to it. So it's pretty powerful tool, I would say.
Wonderful. All right. Thanks very much.
All right, see you next month.